Hey, good Saturday evening, and welcome to Journal Entry. For Module 12, Logistic Regression, this is the last module of the semester, spring of 23. So for this demo, we are going to look at logic regression. So in looking at performing a logistic regression, we are looking to see if independent variables impact a dependent variable. And in this case, the dependent variable is overall problems with sleeping. Our independent variables are age, sex, falling asleep, staying asleep, and the hours of sleep we get during the weeknights. So first we check our assumptions. We check our sample size, and we have a large sample with most of the predictor variables having yes or no answers. So we can run descriptive statistics if we are unsure of our sample size. I ran them as habit and good practice, but we are okay. We are using the sleep.save data set that we have been using all semester long from Julie Pallant's SPSS Survival Manual. Next, we are going to check for a multicollinearity, and to do this, we need to run a multiple regression like we did in the previous module. I will not go into great detail as to how to do this. I am moving from the data set, which has been shared on your screen, to our output. Not quite sure why. Zoom's been acting kind of goofy here. Sorry about that. So we're going to look at collinearity diagnostics, and we're going to look under the coefficients table. And in our collinearity statistics right here, we're going to focus on our tolerance column. And if our numbers are less than 0.1, that indicates a high correlation. So looking right here, that high correlation would indicate a high correlation with other independent variables, in which case we would need to remove some of them. But you can see that our values are much higher than 0.1, so we're okay. Let's move on. Next, we're going to look for outliers. So we examine a graph that was included with our multiple regression. It doesn't form an exact straight line, but there is some linearity in it to not violate the assumption. So finally, to the task at hand of running a logistic regression, and we're going to use our sleep data that we've worked with all semester. The steps for running a logistic regression are on page 178 in Pallet's SPSS Survival Manual as mentioned before. So scrolling back to the top, we get to the logistic regression, and to get this, as always, I'll briefly run through it, but not go through the specific steps so as not to duplicate my data. We are going to go to Analyze, Regression. We're going to come over to Binary Logistic. We would move our dependent variables over here. This is going to be problem sleep recoded to the dependent box. The book states that the values need to be 0 for no and 1 for yes. So there are two sets of data we can pull from, and we need to make sure that we select the recoded data. The other problem, sleep, is not recoded and would mess up our findings. We run into the same thing down here with our independent variables. So after we move our independent variable into the box, we click on our predictor variables, which are sex and age, falling asleep, staying asleep, and the hours of sleep per week. Although not showing it, I did another step. So let me show you. Get a sleep recoded that has the correct coding for 0 and 1. Staying asleep recoded, and just make sure. And hours of sleep, that's just the total hours. You have to make sure that you have the correct information in your chart. Then you put your categorical predictors that you'll need into your categorical button. Categorical, which is sex, getting enough sleep, and staying asleep. Those each just have yes or no or male or female type answers. Then we go to the options button, and all of these instructions are in detail in Palant's book. Make sure that classification, statistics, and plots. We need to check off classification plots. We need to check off the Hosmer limb show goodness of fit. We need to check the case-wise listing of residuals. Make sure that the radio button for outliers outside 2 standard deviations is selected. Display at each step. The CI for XBB at 95% is selected. We need to check the include constant in the model, and the rest is automatically set that you need. You're going to click continue and OK, and that'll run your logistic regression. Now we need to look at the data and interpret our results. So we're going to check our sample size in the case processing summary. So we're going to look for our case processing summary. We come down here and find it. We have a total in of 271 cases. And as you can see, 30 cases are missing. So only 241 cases are considered in the analysis. In the descriptive statistics, way back here at the beginning, you will see that 271 people answered the question for sex, male or female. That 271 in minus the 30 missing cases matches up to the 241 included in the analysis. So we are good on the number and we can go forward. This shows our number is good. Now we need to check the dependent variable encoding chart. That is right here to make sure that 0 is no and 1 is yes. So you can see our original values of no and yes, and our internal values of 0 and 1. Next, we check the coding of the independent variables in the categorical variable codings chart. We have no's and yes, no is 0, yes is 1, all the way down, then female is 0, and male is 1. Also, if you add the frequency of each section, they all add up to 241. 151 and 90, 138, 103, 140, and 101. Each of those groupings adds up to the 241 magic number we're working with. If you come to the section block 0 beginning block, the block 0 section and everything underneath it shows the results of the analysis without independent variables, and it serves as a baseline for us. In the classification table, it shows that 57.3% of the cases indicate no problem with sleep. Now, if we move down to block 1, The omnibus test of model coefficients tells us how well the model performed. The significance value should be less than 0.05. So we are in good shape there because they are all less than 0.05. It also tells us that the chi-square is 76.020 with 5 degrees of freedom. If we report our results in APA style, we will need that information to report. Our trusty APA 7 manual explains to cite all of this wonderful information and how to do it. In the Hosmer limb show test, we want a value of greater than 0.05 in the significance column. In this case, our significance value is 0.264 with a chi-square value of 10.019 and 8 degrees of freedom. So this is acceptable and supports the model. The classification tables in block 0 and block 1, classification table block 0, classification table block 1, can be used to predict how well the model can predict the correct category for each case. Back here in block 0, we already determined that 57.3% of cases were predicted with accuracy. In block 1, that considers your independent variables. We are showing an overall percentage, 75.1% cases were predicted correctly with predictor variables included in your independent variables. The variables in the equation table right here tell us the importance of each predictor variable, and we look at the significance column for values less than 0.05. Anything less than 0.05 contributes significantly to the predictive ability. In this case, problem staying asleep, getting asleep, 2.046, and hours of sleep during the weeknights are major factors in whether a person reports having problems with sleep. So next we check the B column for positive and negative numbers over here in the same chart. If no's are coded 0 and yeses are coded 1, then the negative values indicate that an increase in the independent variable scores will result in decreased probability of your issue occurring. So for example, if we look at the B value of hours slept during the weeknights, which is negative 0.448, this means more hours of sleep per weeknight a person gets as that independent variable score increases, the less likely that person will report they have trouble sleeping. For problems staying asleep, the B value is positive. It's 1.984, which means people answering yes to this variable are more likely to indicate overall that they have a sleep problem. In the variables in the equation chart, the 95% confidence interval ranges tell us values that can mean 95% confident as values of the odds ratio. The odds ratio is this XB column, and these are our confidence intervals ratios lower and upper. So a logistic regression was performed to determine the impact of independent variables, sex, age, problems falling asleep, staying asleep, and hours of sleep on weeknights. Have an hour. The dependent variable of problems sleeping, the variables of getting to sleep, staying asleep, and hours per week made a significant contribution to the reporting of overall sleep problems. Age and sex did not have a significant contribution, so your age, your sex really did not affect whether these participants reported they had trouble with sleep. So in our results, we would emphasize that the three factors of falling asleep, staying asleep, and hours of sleep had the greatest impact on the dependent variable of sleep problems, having sleep problems in general, and that is how we perform a logistic regression. Thank you for joining me for Module 12 on logistic regressions. Have a good night.